Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Lightning and Gravity in the Earth's Atmosphere. Now, the observation of stellar cores in the sun's corona has led me to develop a new understanding of what gravity really is. How I developed this understanding is detailed in my book entitled Planet X Revealed Gravity and Light. And it's also explained in Article 182 entitled Einstein's Dream Realized, Unified Field Theory of Electrogravitation. In this article, I use this understanding and apply it to the Earth's atmosphere. This understanding will lead to an understanding of how electrogravitic propulsion can work in the Earth's atmosphere. But here I just explain the mechanism behind lightning. The electron, and this is explained in Article 278 entitled Planet X and the Electrons, the primary carrier of gravitational energy, plays a very important part in this understanding of gravity, and thus the mechanism behind lightning. In the same way that the electron is the primary particle in chemical reactions and in ionization and thus light emission, the electron is also extremely important in the understanding of gravity and gravitational energy levels. Now, the theory of electrogravity is due to two interactions, the electrostatic interaction and the true gravitational interaction. And these interactions are similar and oppose each other. The electrostatic interaction causes protons and electrons to attract each other, two protons to repel, and two electrons to repel. The strength of the interaction is the same in all three cases. Now, in the gravitational interaction, we have the opposite. And in addition, the strength of the interaction depends on the amount of photon energy inside each particle. So there is an asymmetry between the two, even though basically they are opposites, but the forces of interaction between a proton and an electron is different from what it is with two protons. So this leads to the observed structure we see in the universe, where all objects from atoms to galactic nuclei have a dense proton rich and positively charged interior and a negative electron rich outer layer. Celestial bodies like the Sun or the Earth operate much like atoms and can therefore be called superatoms. In an atom, an electron can observe a photon, which causes the electron to gain gravitational energy, which in turn increases the repulsion between the electron and the protons in the nucleus, which causes the electron to move to a higher energy level. And here we have an atom which is made up, this is a hydrogen atom. It only has one proton and one electron. This is the nucleus. It only has one proton in the nucleus. And then there's an electron in an energy level orbiting around that nucleus. So it has a positive core or interior and a negatively charged outer layer with one electron in it. Now, all other objects in the universe are like that, except they have huge numbers of particles, but they are still positively charged at the center. They have a positively charged core and they have a negatively charged outer layer. And not all energy levels, not all positions are allowed here, which means that these are quantized. In the same way, we are likely to have energy levels that are quantized with celestial bodies as well. But because they may be so close to each other, at least in the atmosphere of these objects, it may not be noticeable. Now here what's illustrated is how when an electron absorbs a photon, it tends to move away from the nucleus. So this is an atom with 3 protons, 1 neutron. The neutron is a combination of a proton and an electron, so it's neutral. The protons are positively charged, the electrons are negatively charged. The forces between the protons are so strong that they combine and form a dense nucleus, and this forms the center of the atom. The electrons are then attracted to the protons because of this electrostatic attraction. But there is the gravitational interaction which opposes it, and that's illustrated by the green arrow. Now there will be, at a certain distance from the nucleus, the 2 forces will be in equilibrium. So that means that the electron will stay in the region where the 2 forces are in equilibrium. And this is why it then orbits or moves in that region outside the nucleus. We see the 2 arrows should be about the same length because these are 2 forces in equilibrium. But now if an electron absorbs a photon, it gains gravitational energy, and when it does that, the gravitational repulsion between it and the protons in the nucleus increases. In other words, the green arrow will increase in size, and that means that the photon will move away further up to another energy level where the 2 forces will then again be in equilibrium. Or if it gains enough energy, it may actually leave the atom entirely, in which case the atom will become ionized because it would have lost 1 electron, and then it has too many positive charges. It will have 3 positive charges. It'll only be left with 2 negative charges, so it has 1 extra. It will become a positive ion. Now the same thing can occur in reverse. An electron which is captured by an atom or moves to a lower energy level will release photons. In other words, it will emit light. And this is illustrated here again, how whenever an electron moves down from a further out energy level to one closer to the nucleus, then a photon is given off. And when an electron absorbs a photon, then it gains energy, so it moves to a higher energy level. This also means that as we move further away from the nucleus, we get energy levels that have an energy associated with them that is higher. So energy increases the further out we move from the nucleus. Now the Earth also has electron energy levels, just like the atom, but we do not only find electrons in each level. Instead, there are neutral atoms, positive ions, which are atoms with missing electrons, and free electrons at all levels. But the charge and thus the electric potential in each level increases as we move further away from the center of the Earth. The photon energy in the electrons at each level also goes up as we move further away from the center of the Earth. In addition, each level will have a tendency to split into an inner, more positive side where positive ions or protons predominate, and an outer negative side where electrons predominate. This is also why the Earth's Van Allen belts have an inner positive region where protons accumulate and an outer region where electrons are found. And these are the Van Allen belts. They contain particles that come from the sun, from the solar wind, but the protons will go into an inner layer and the electrons stay in an outer layer. And this is, of course, because the protons are attracted to the Earth's core, whilst the electrons are repelled by the Earth's core. So the electrons go further out from the center of the Earth. Now, so this is an illustration of the energy levels in the Earth's atmosphere. This would be the surface of the Earth. It is at an energy E naught, and energy goes up with altitude. So we have somewhere in the atmosphere, we'd have an energy level E1, and this would be the energy level associated with the ionosphere. And that will be the highest shown here. And so as we move up, the energy increases. Now, we also have different amounts of positive and negative charge at each level. At the surface of the Earth, we still have more negative than positive charges. But further up, we would have even more. So the number of charges at each of negative charges at each level goes up as we move upwards. And that means that the electric potential goes up as we move up through in altitude. But it's negative. So we could say the absolute value increases as we go up. But it's negative because it's to do with a greater number of negative charges. So we have more electrons at each level as we move up, and we also have the electrons at each level as we move up having more photon energy or gravitational energy inside them. And then we do have a certain level where the potential is 0. And I've placed it here. I think it's likely to be just below the surface of the Earth. Although I cannot be sure of that. It could be just above the surface. So I think it's more likely to be just below the surface of the Earth. And then we would have positive potential below this. Now, the energy levels below the surface should always be about the same, because in the solid crust, the solid part of the Earth, the particles are in close contact. So the energy will be shared quickly between particles. So there should be about the same amount of gravitational energy in all the particles. Although there is energy flowing from the core, but it quickly flows to all particles that make up the solid part of the Earth. So we have charged particles from the Earth and the solar wind meeting at the ionosphere. So, and this means that we're going to get more electrons and the concentration of electrons sometimes increasing in the ionosphere because there are electrons coming in through the solar wind. And this is why this region often will drive lightning, storms, and so on. And I explain in the next diagram how lightning then occurs. So the solar wind protons form a layer below the electron layer. So as you can see, we have protons below the electrons. And that is again because protons are gravitationally attracted to the positive core, whilst electrons are repelled. The electrons don't leave though, because they are still electrostatically attracted to the Earth's core. So we have always the two interacting, the negative and the positive charges be interacting through both the gravitational and the electrostatic interactions. So the energy level at the surface and inside the Earth will tend to be the same as all the particles in the solid part of the Earth, because they are in close contact, as I mentioned. Now, lightning or electric discharges between different points occurs when the concentration of electrons at a certain altitude increases beyond the point which the gravitational interaction can no longer support. So the electrons drop to a lower energy level, which causes them to release photon energy or photons, and therefore light. So this is explained in this diagram. So we again have energy levels. We have the Earth's surface. We have this positive electric potential level within the Earth, where we would have a certain concentration of positive charges due to the concentration of protons in the atoms making up that layer. And that layer has a corresponding negative potential layer in the Earth's atmosphere. And it is the gravitational interaction which causes electrons to be repelled by the positive protons in the layer inside the Earth, that allows a certain amount of negative charges to be supported at this altitude. So lightning occurs when this concentration of electrons in this layer is higher than what the corresponding proton layer, this one here, below the surface of the Earth can support through gravitational repulsion between protons and electrons. This causes the electrons to move to a lower altitude, which is at a lower energy level. So the concentration, say here, is too high, too many electrons there, so that causes electrons to move down to a lower energy level, which then causes these electrons to release photon energy or photons and thus emit light. The emitted photons are observed as lightning. So this is why we then see lightning being emitted from perhaps most of this region. As the electrons move downwards, they emit photons, and we see this as lightning. So in conclusion, the application of electrogravity theory principles, a theory which came from the observation of stellar cores in the sun's corona, is able to explain the process of lightning in the Earth's atmosphere, arising from electrons moving to lower energy levels. The process is very similar to what occurs in atoms. A similar process will be at work in the sun, leading to the sun's emission of light from its atmosphere. And here are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.